Stefan, why is it doing that?
Because it gets so cold, doesn't make bubble in the water.
Good job. And what's that? That's
Good.
science. Good job. Go science, yeah?
Yeah.
You say, go science.
Good.
Eilish, do you like science? Good girl. Here we have some solid carbon dioxide. It's referred to as dry ice. So it's carbon dioxide, which is of course usually a gas at this sort of temperature. But if you get it less than about minus 78.5 degrees Celsius, it's as a solid. So what we have now is this very, very cold solid carbon dioxide. It's getting heated up just in the ambient temperature. It's actually pretty cold in camera right now, but it is turning into a gas. You can see vapors coming off. The vapors you can actually see isn't the CO2 gas. That's actually tiny droplets of water. It's so cold that it cools the air down around it, and so the water in the air starts to form tiny droplets. That's actually what we're seeing there. We can see that a lot more if we drop it into some water. So what we're essentially doing is making clouds. That's what clouds are, little water droplets. So it's not the CO2 that we're seeing, it's not smoke as such, it's tiny little water droplets that are being cooled down in the air because the dry ice, the solid CO2, is so very cold. Another thing we can do with dry ice is to make music. Well, I don't know if I should call it music, but let's get that out of the way so you can see this. If we put a knife on top of it, the knife squeals rather. Quite cold outside, so the knife itself is quite cold. If it were warmer it would be squirting more, but now remember this solid, get rid of that so the camera stays focused. The solid CO2 is turning back to a gas, but it's doing that from all around the piece of dry ice here. So when I put the knife down on it, gas molecules will be being given off on the upper surface, which is making the knife blade vibrate. So because the blade of the knife is vibrating, that's making this sound. This would of course be one way to cool your drink down. If I put my hand in the water, yeah, that's really cold. Whew. Don't want to leave my fingers in there too. You could cool your drink down like this. You would of course have to wait, if we drank it, until all of the solid CO2 had gone, had converted back to gas. But also your drink would now be slightly acidic, because we're actually making carbonic acid. CO2 dissolved in water, as it bubbles up through, some of the CO2 gets dissolved and makes carbonic acid, a weak acid. So here we have some water in a beaker. We add some universal indicator solution. We can see that it's a nice green color. Water being neutral. Universal indicator solution is green. There we go, let's do it. Now we can see the green color. Universal indicator solution is green in neutral solution, blue or purple in basic conditions, and yellow, orange, red in acidic conditions. So what I'm just adding now is a little dash of sodium hydroxide solution. Sodium hydroxide, of course, being a strong base. So our solution now is very definitely a basic solution. I've also got some dry ice here. If we put some dry ice into this basic solution, we should see a couple of color changes. We should leave the basic purple and go through the neutral green and then into the acidic yellow, because the carbon dioxide, some of it will be dissolving in the water and producing carbonic acid. So we will first neutralize the base and then go further and make an acidic solution. Let's have a look. Purple's fading, we went blue, there's a green and yellow. Let's see how acidic we can get it, how low we can make the pH. It's definitely orange now. So I've gone past the yellow, we're into orange. Red, as an acidic solution, would need to be pretty low pH, sort of down around pH 2, so I don't expect it to go red, but that's a definite orange there. Here we have a candle, burning quite nicely. Next to that, some dry ice in a beaker. Now, of course, the dry ice is turning to a gas. It does this without melting first. It doesn't go to a liquid first. It goes from a solid straight to a gas. So we call this sublimation. We say that dry ice sublimes from a solid to a gas. So what I'm going to do now is just pour from the beaker. Of course, we can't see carbon dioxide, but there should be some in the beaker. Carbon dioxide is a heavier gas than air, so it should still be sitting in the beaker, which means I should now be able to just pour some carbon dioxide onto the candle, which of course extinguishes the candle. I'll just do that again, so I'll relight the candle, and then I'll take my match and I'll put it into the beaker, and it goes out, because remember we have carbon dioxide gas in the beaker. And so put the match out and we can pour. Let's just focus on the candle, that's better. We can pour out the CO2 to put out the flame. So another fun thing to do with dry ice, solid CO2, is to make a knife blade or metal spatula, something metal, squeal. As the CO2 is cool, that was a long one. As the CO2 is subliming into a gas, when we push down on it with something metallic, the metal vibrates. because the gas is, of course, being given off in all directions off the solid CO2. So when we push either a knife blade or a metal spatula, when we push it down on the dry ice, it vibrates. And of course, when something vibrates, that's how we make noise. It's from something vibrating. You'll also notice the dry ice quite happily slides around on the bench because it's also tuning gas underneath, so it's kind of hovering like a little hovercraft on a cushion of CO2.